Good morning. Myself SUDIPTA, Assistant Professor of Mechanical Engineering Department, and today I am going to discuss about the mechanical properties of governor. So what is a governor and what is its function? Governor is a mechanical device which actually regulates the different need and the requirement of engine during the variation of load when it is in running condition. Other than engine, it can be also used in different types of prime movers, in case of turbines, in case of generators, and some of other devices. So let us see that how they are classified. So basically, governors which are commonly used, they are of different types. One is centrifugal types of governor and one is inertia type of governor. Now this centrifugal type of governor, they are subcategorized to mainly two types. So these centrifugal types of governor, they are also subcategorized into mainly two types. One is called as pendulum type and the other is the loaded type. The loaded type of governor is also again subcategorized into two types. One is dead weight and one is spring control. Now let us discuss about each one of them. First, pendulum type of governor. This is the very first type of governor or the basic type of governor which were first invented, and they are watt governor. The second type, that is the loaded type, they are subcategorized into two different types. One is dead weight and one is spring control, as I told. So these dead weight type of governors, they are also up to two kinds. Now coming to the spring control type of governor. If we closely observe and analyze each one of them, then we will understand that the first one, that is the watt governor, was modified to motor governor and it was further modified to PROF governor. Then when we added some spring in it and made some other type of adjustment, regulation and modification, then we came up with Hartnell governor, Wilson Hartnell and Pickering governor. So these are the basic 7 types of governor which are commonly used in mechanical devices. Now let us discuss about the very basic of the watt governor. In case of watt governor, this is a schematic diagram, but you can see that there is a rectangular part at the bottom which is called as the sleeve, and at the top these two links from the either side, they are connected as a fulcrum. This can be considered as point O. Now this left hand side of this central part, which is called as the spindle or the main rotating part. So left hand side and right hand side are completely mirror image or identical to one another. That means whatever the mass or all other sizes and adjustment in the left hand side we are doing, exactly the same thing will happen in the right hand side. So for our calculation purpose, what we used to do, we used to analyze only one half of the governor, commonly left hand side of the governor, and we get the same result in the right hand side, just in opposite direction. So in case of governor, there will be a ball mass over here, and when it is rotating due to the centrifugal force, the ball mass is having a tendency of moving in the outward direction. This is FC. FC means centrifugal force, and the common term of FC equal to m omega square r. Numerically, we explain it that way. And the self weight of the mass, that is mg, which is acting in the downward direction. So during this phase, if somebody want to know what is the height of the governor, then the common process is to mention that this one from here to here, this is the height or edge of the governor, and the radius of rotation is from the center of mass of the ball to the center of the spindle of the rotating axis. So this is called as the R. So it is obvious that when the governor is rotating at high speed, R will increase and accordingly the H will reduce. But do not consider that this relation is linear always. That means the change of H is not always linear not always linear. Now, what we are going to find out, first we need to know, we are actually going to find out or establish a relation between the RPM, that is age, and what is the height of the governor, or the R of the governor and age of the governor. What is the relation between them? But commonly we want to find out the RPM or N to height or age of the governor. This is the common criteria. In case of what governor, what we used to do, we take the moment with respect to point O. So, with respect to point O, there are two active forces, one is Fc and one is Mg. So, for Fc, we know that H into Fc, that should be equal to Mg into R. So, this is obvious. So, Fc equal to M omega square R into H, that should be equal to M into G into R. So this R and this M, they are eliminated from either side. Now omega equal to 2 pi into N by 60. This is whole square multiplied by H, this is equal to G. Now, important thing to understand that this section or this part of this equation is a constant term, that is 2 pi divided by 60. So what we are doing, n square equal to, what we are doing, that is n square equal to G by 2 pi by 60 whole square into 1 by H. If I continue this equation on this side, then we are getting, that is H equal to G by 2 pi by 60 whole square to 1 by n square. Closely look that this n and h, I have interchanged the place. So now this part of this equation, if we calculate, then we are going to get h equal to 895 by n square, or n square equal to 895 by h. So this is a very common term that we are going to find out from this what government, and this is what exactly we are going to find out. So for today's class, I am concluding over here. We will continue in the next class with further information on different types of governor and numerical problem. Thank you very much.